Look up into the night sky. Among the countless stars, one glows with a steady reddish hue, Mars. For centuries, this fourth planet from the sun has captured our imagination, both familiar and alien. Its rusty color hints at untold stories and mysteries beneath its frozen surface. Mars is more than a distant world. It's a puzzle, a story waiting to be solved. We send robotic explorers, driven by curiosity, to uncover its secrets. Each discovery, each image, each rock, adds a new chapter to our understanding. The possibility that Mars once harbored life is one of humanity's most profound questions. Studying Mars helps us understand planetary evolution, and perhaps our own future. Once it may have been warmer and wetter, a world not unlike early Earth. What changed? Why did its path diverge from ours? The answers could shape our destiny. Mars is a cosmic laboratory, a time machine revealing the past and possible futures of rocky worlds. When you see that red point in the sky, remember, it's a symbol of our drive to explore and understand. The journey to Mars is a journey into the heart of what it means to be human. Long before telescopes, ancient civilizations watched Mars move across the sky, its blood-red color impossible to ignore. The Romans named it after their god of war, seeing it as an omen of conflict. The Greeks called it Ares, also a symbol of strife and fury. Babylonians saw Mars as Nergal, a deity of destruction and pestilence, tracking its movements to predict disaster. In Egypt, Mars was Herdesher, the Red One, linked to powerful gods and cosmic forces. Across cultures, Mars inspired awe and fear, its redness a universal symbol of power and danger. These myths were humanity's first attempt to explain the mysterious wanderer in the sky. Without science, they wove stories, connecting Mars to the most intense aspects of life on Earth. These ancient tales laid the foundation for all future exploration. They remind us that our fascination with Mars is as old as civilization itself. The Red Planet's story began in myth, but it continues in science. Our quest to understand Mars is rooted in the same impulse that made our ancestors look up and wonder. The first chapter of our relationship with Mars was written in the stars. The telescope revolutionized our view of Mars, transforming it from a red dot to a world. Galileo saw Mars as a disk, not a god, marking the start of scientific observation. Christian Huygens sketched Syrtis Major and calculated Mars's day, almost the same as Earth's. Improved telescopes revealed polar caps and changing seasons, hinting at a dynamic planet. Mars began to look like a sibling to Earth, with weather and climate of its own. In 1877, Schiaparelli observed canali, channels, mistranslated as canals. Percival Lowell mapped these supposed canals, imagining a dying civilization building vast irrigation networks. The idea of Martian engineers captivated the public and inspired science fiction. But better telescopes revealed the truth. The canals were optical illusions, not alien structures. This episode showed how our hopes can shape what we see, and how science corrects itself. The myth of the canals faded, replaced by a more accurate, if less romantic, understanding. Mars remained mysterious, but now it was a real place, not just a canvas for our imagination. The age of the telescope taught us to question, to verify, and to keep searching for the truth. Each new discovery brought us closer to the real Mars. The Red Planet's secrets were waiting for those who dared to look deeper. Mars is often called Earth's twin, but it's really a smaller, older cousin. Its diameter is half of Earth's, and its gravity is just 38% as strong. This weak gravity means Mars couldn't hold on to a thick atmosphere. Over time, solar winds stripped most of its air, leaving a thin, carbon dioxide-rich atmosphere. Temperatures swing wildly, and there's no breathable oxygen. Mars orbits farther from the Sun, so the distance between our worlds constantly changes, from 34 million to over 250 million miles. These differences make travel and communication a challenge. Earth is vibrant. With strong gravity, thick air, and oceans, Mars is cold, fragile, and exposed. Understanding these contrasts helps us appreciate what makes Earth special, and what we'd face living on Mars. Mars and Earth are two outcomes of planetary evolution, shaped by size, distance, and fate. Their stories are written in the same solar system, but with very different endings. Studying Mars reveals the delicate balance that sustains life on our own planet. The Red Planet is a reminder of how rare and precious Earth truly is. Mars is a world painted in red, its color the result of iron-rich rocks turned to rust. Fine dust covers the planet, whipped up by winds into massive, weeks-long storms. Mars boasts the solar system's tallest volcano, Olympus Mons, and the vast Valles Marineris Canyon. These features dwarf anything on Earth, revealing a planet shaped by titanic forces. The climate is harsh. Daytime at the equator can be mild, but nights plunge to deadly cold. Mars has polar ice caps made of water and dry ice, growing and shrinking with the seasons. Most exciting is the evidence of ancient water, riverbeds, deltas, and rounded pebbles shaped by flowing streams. Billions of years ago, Mars was wetter, with lakes and rivers. Today, water survives as ice beneath the surface and in the poles. The story of water on Mars is the story of a world transformed. Its surface holds clues to a lost era, when Mars may have been more like Earth. Exploring these clues brings us closer to understanding the planet's past and its potential for life. Mars is a frozen desert, but its history is written in rust and ice. The search for life on Mars is one of science's greatest quests. Billions of years ago, Mars had rivers, lakes, and a thicker atmosphere, conditions that could have supported life. In 1996, a Martian meteorite sparked debate with possible signs of fossilized microbes, but the evidence remains inconclusive. Today we search for biosignatures, chemical or physical traces of past or present life. NASA's Perseverance rover explores Jezero Crater, an ancient river delta, collecting samples for future return to Earth. If life ever existed on Mars, its traces may be locked in these rocks. Even the discovery of simple microbes would be historic, proving life is not unique to Earth. Such a find would suggest life could be common throughout the universe. Our robotic explorers dig, analyze, and search for any whisper of a biological past. The answer to "Are we alone?" may be buried in the Martian soil. The search continues, driven by curiosity and the hope of a cosmic connection. Mars may yet reveal that we are not alone in the universe. Mars exploration is a story of ambition and innovation. NASA's Viking landers in 1976 sent back the first color photos and analyzed Martian soil, laying the groundwork for future missions. The Pathfinder mission in 1997 deployed Sojourner, the first rover proving we could drive on Mars. Spirit and Opportunity, landing in 2004, found proof that water once flowed on Mars, far outlasting their planned missions. Curiosity, a car-sized rover, has studied Gale Crater since 2012, revealing Mars's complex geology. Perseverance, landing in 2021, searches for signs of ancient life and collects samples for return to Earth. Ingenuity, a tiny helicopter, made the first powered flight on another planet, opening new exploration possibilities. Mars exploration is now global. China's Zhurong rover and the UAE's Hope orbiter joined the quest in 2021. These missions study everything from surface rocks to the Martian atmosphere. Together they form an international fleet, each mission building on the last. Robotic explorers are our eyes and hands on Mars, unlocking its secrets one discovery at a time. The red planet is no longer alone, it is being explored by a fleet from Earth. Sending humans to Mars is no longer science fiction, it's a real goal for space agencies and private companies. The challenges are immense: deadly radiation, weak gravity, and a hostile environment. Astronauts will need shielded habitats, advanced life support, and ways to extract water and air from the Martian soil. The journey itself takes months, with health risks from weightlessness and isolation. Survival will depend on technology, ingenuity, and teamwork. Colonists must grow food in greenhouses, recycle every resource, and adapt to a world with no safety net. Despite the risks, the rewards are huge: a second home for humanity, new technologies, and a new chapter in our story. A Mars colony would make us a multi-planet species, ensuring our survival and inspiring generations. The first humans on Mars will be pioneers, facing the unknown for the sake of all humankind. Their journey will test our limits and redefine what's possible. Mars is the next great leap for humanity. Mars is more than a planet, it's a mirror for our hopes, fears, and dreams. In ancient times, it symbolized conflict. In the age of telescopes, the hope of life beyond Earth. Today, Mars challenges us to explore, innovate, and work together. Studying Mars gives us perspective on our own planet's fragility and the importance of protecting it. The red planet is a cautionary tale and a source of inspiration. The coming decades promise a golden age of exploration, sample returns, new rovers, and perhaps, human footprints. Mars is the next step in our cosmic journey, a symbol of human potential and curiosity. For millennia we've wondered about that red dot in the sky. Now we're on the verge of visiting. The challenges are great, but so is the promise. Mars calls us to reach higher, dream bigger, and become citizens of the solar system. The adventure is just beginning. What role will you play in humanity's next great journey?